Alright, cool. So, as everyone knows, my name is Justin Herron. I'm the Principal Cloud Architect at Tampa Devs. Thank you all for showing up. And thank you for HTC as well for sponsoring this whole event. We have Professor Sharon Moran back there, as well as the Dean, Chris Painter. I'm not sure where he is at the moment, but just wanted to say a massive thank you to them, because without them gracing us with this space, this would not be possible. So just want to give a big round of applause.
Hey, good afternoon, good evening, everybody. Got a chance to meet some of you in the parking lot. My name is Chris Painter. I don't know if that part came out yet, but I'm proud to serve as the Dean for the Associate in Science Technical Programs here at the Dale Mabry campus of Hillsborough College. You've probably been hearing a lot about us lately, a name change, and some other things that are in the news lately. But we're really excited to be able to host an event like this in our Center for Cybersecurity. This center was a vision of Professor Sharon Moran, who you'll probably already know or get to talk to if you haven't already. And it's one of the really centerpieces of our technical education here at the college. Cybersecurity program is one of the biggest that we have here. It's the fourth largest technical program at the college. We serve a ton of students here in business, computer science, and a wide variety of other programs as well. I'm really excited to learn and listen and get to hear what's happening, and it's going to help us understand what's going on. And we're always interested in hearing from you, hearing what's going on, and it eventually informs our programs and it helps our students. So we really appreciate you being here. I don't know if there's anything else or who I'm turning it back over to, yep. So I'll flip it back over to you. And thank you for being here.
Yep. Thank you so much. Okay, so without further ado, I'll turn it over to Connor. He's going to go over some fun stuff. So.
Well, hey guys. I mean, this is a cool room, so I don't exactly know where I'll look the whole time since there's screens here, 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 and behind me. And I might be blocking one of them, but if this is good, I'm good. So, thank you. Okay, so what I'm going to do if this clicker works is I want to talk to you guys all about, because I've been working now 10 years, director of engineering at SourceCode, and just building software, and we're using more and more AI. But because I don't want to jump right into that, I'm going to start you off with like the beginning of the LLM. We're going to jump between, starting with GPT-1, we go all the way to 5. I'm going to look at tools, and what I mean by that is like, how is the LLM working under the hood? We'll talk about that. And then I'm going to get into something that, is like what I'm using in the workplace with AI to empower my work, and then building with AI, and then like software I use to help my AI solution. So we got a lot to go through, but as you can tell, I talk fast, we move fast, and that's what we're going to do. So I kind of already talked about it, but the more important thing here is that little iBotPeaches. It's been the same username for 20-something years now. So if you recognize that from Halo hacking, Xbox, Ingress, Android, that's me. It's been the same forever. So pretty cool. Been at SourceCode, as I mentioned, director of engineering. But what I wanted to thank is, I just won Emerging Tech Leader of the Year a couple weeks ago. So I know a lot of you guys voted. Yeah. Well, thank you. Some of you guys were there. It was really fun, and I never thought, compared to some of the people I was against, that I would win. But ultimately, I'm a mega nerd, and it was cool to get some, recognized for it. But I did not want to jump to that yet, but I already showed it off. Is I was going to ask everyone, like, anyone know how this AI craze started? And unfortunately, I already spoiled it, but the title of this paper, came out in 2017, and it was called "Attention is All You Need." And the interesting thing about this paper is it was kind of like an equally sided between a bunch of Google scientists that kind of agreed when they were done with this, is they were onto something. And does anyone know what was kind of invented here, what you would call this thing? Transformer is basically what they invented. And if you worked in machine learning prior to this, or any type of AI work, like without transformers, things were slow or harder to work with. And when transformers came around, you could parallel their work and accelerate everything you were doing. And it all started from this paper, which became immediately cited from in tons of businesses, and spawned what you're seeing now is kind of the AI craze with everyone building on top of transformers. And I wanted to jump into transformers, but unfortunately they are mega complicated for a talk. So this is the only slide we're gonna look at, because to really go through a transformer is extremely technical, and it's probably not worth it for this discussion. But ultimately what you wanna know is a transformer can accurately predict, the next token or a letter of a word with some crazy math. And we could go into that at some point, but for now, that's not what we're going through. So now we're going to go through GPTs, and we're going to start at the very beginning, go to 5. I think everyone knows 5, but probably a lot of people don't know 1 or 2. So we'll kind of start there. And in the very, very beginning, GPT-1, this was like the investigation, the research phase. And what did you have back then? You just had books. And what they were doing is training models based on looking at research books to figure out if they could have a conversation with, an agent trained on books. But the problem with this is it was like tokens in and tokens out. And when I say that, like what even is a token? And I kind of have this little graphic here so that you can see is like when you're communicating with an LLM, its goal immediately is tokenization. Step 1. Take whatever you're putting in, whether it's, audio, text, and tokenize it into something it can work with, which becomes, ultimately numerics that you can see that can kind of get spec'd in a 3D space. So you can see here, this is a rough, hello, my name is Connor. But what I want you to look at in this coloring here that you can see is my name is split off in the middle. And that's what's important with tokenization, is how does this process work? Like obviously hello is a token, my is a token, but my name, formal words are nouns. Like this gets split off because or, is clearly a word, but together, Connor's a word. Which is why you see sometimes when we get further into this, like predicting the next letter or counting is difficult and tokenizing. Generally, most issues you see with LLMs these days always start with tokenization. So then we jump into GPT-2, which was roughly a year later. And what they did in GPT-2, which kind of coined this term, which was called zero-shot training. And what that meant was once you had a model, could you immediately ask it your thing, your topic, your question, and it would respond with zero pre-training or post-training, just from scraping content, training a model. And zero-shot training with an increased token limit was kind of next generational. It was like, wow, we are starting to get, if you were around during the AIM days, the Smarty bot, like you were getting that level of conversation with a model in GPT-2 that was crazy, almost human-like. And this was 2019. So naturally, what did we do after that is GPT-3 came out. And this was, of course, the commercialization, the one that you know today. It's confusing like what this one was trained from. People predict, it was a good chunk of the internet, and now we know it was like honestly a huge chunk of Reddit was a large part of it. But does anyone know, how fast, because on this next slide here, how long it took OpenAI to get to 100 million users? Any random guess out there?
4 years. 6 months.
6 months, 4 years? Okay, it's kind of crazy. They did it in 2 months. 100 million users. And just think about the scale of 100 million users. When you look at this little graph here, you can see, you'll probably recognize a few of the logos. TikTok was pretty crazy to do it in under a year, and everyone thought that was insane. But to do it in 2 months, to get 100 million, crazy. I still use Spotify every day, so it's good to see they're still up there on the chart for myself. But otherwise, you can probably recognize all those logos, and pretty crazy for them to get to that mark. But now what I want to talk about is like how you were communicating with the models if you were trying to develop something. Is when GPT-3 came out, you had this endpoint that was called completions. And as the name suggests, it was basically your ability to get a completion from a model. And it had a few parameters in it that all corresponded to like how a transformer worked. And these are a bit technical, but as you went through a transformer, what is the bias to pick a letter? Like when you look at the end, what do you seed from the beginning? What is your temperature? Which is like how often do you pick a different one or switch around? You could control all these values when using it. And what's crazy about the completion model is you could give it tokens. You didn't even need to give it, human words. You could give it tokens and get back tokens. Very nerdy, very odd, but this is what people started with. And I forgot about top P. Another one that helps you like pick when you are working through the transformer is which value. But we don't care too much about that because things were moving too quick, which, a couple of years later, is when things really started changing with GPT-4, when we had like the multimodal approach. And what do I mean by that? I mean, like, you have your audio, your photos, your text. It's now your model can do a bit more than text. And this time our token limit went up massively. We started from like 500, 1,000. Now we're at 32 kilobytes of a token limit. And now that we know a word is roughly around a certain token limit, you can think, I can really give it a lot of stuff and get a response back without chunking my messages. And that was pretty cool. But everyone know then when GPT-4 came out that we had a new endpoint. And they were starting to get away from this idea that you can configure or control the parameters of a model. And why did this happen, which is interesting enough, is people found out that because ultimately when you're looking at an LLM, you can do some pretty cool matrix math, is people were nullifying some values and just spamming calls, and they could reverse how the model worked. So GPT, the previous 1, 2, 3, that had access to an older endpoint, people could reverse them. That's how we figured out parameter counts or how they operate. Because you could ultimately send tokens in, set some control values, and do it over and over and over and over and over. Basically, brute force your way to understanding a model. So they panicked and made a new one. They just added a prefix of chat in front of it and eliminated all those parameters. So you could not do that anymore. But this was a pretty cool one because it actually started adding more features, which was this new idea of an assistant. So, around GPT-4, an assistant came out. And what do I mean by that? Like, you send a message to a completion model. You get text back. That's not very cool. Like, you need something that remembers a state. It has a context. It can do things. You can reassociate it with it later. And that was, of course, the Assistants API, which unfortunately for OpenAI, they kept it in beta forever and then ultimately ended it for this new one, which we will call the Response API. This is what we still use as of today, and it's 2026 now. But the Response API blew all the other APIs out of the water because it could do everything. It was multimodal. You could give it images, text, audio, and you can get back text. You can get back audio. Whatever you need, Response API can do it. And it has all these tools, as you see at the bottom, which we will get to very shortly. But then we have to jump to GPT-5, which is a very, very big one, because this is the very first time OpenAI came out with a model that allowed you to pivot between a reasoning model and a completion model. So what we've talked about all thus far has been completion model. You give text, it tries to complete. But people, and, different companies too, kind of saw it with Claude and Anthropic. They were, messing around with this idea of pre-planning, or a model that would first plan its, approach and comment before working. And that became codenamed as reasoning, which GPT-5 was like, that's a bit complicated. I'm going to give you, how long do you want me to think, between auto and pro, which is, how long do I plan my response before giving it to you? What's scary about GPT-5 though, is we really don't know what this was trained from. And you have to think about, now that we're in 2025 and new models started coming out, if more and more of the internet is LLM generated content, where are LLMs in the next level of models getting their content to train from? Because ultimately you'll have a curve that sort of reverses itself if they're getting trained on the same kind of content they are making. So not knowing ultimately where a good chunk of GPT-5 is from is, one, maybe could be concerning where you sit, or two, curious. Ultimately, there's no public knowledge of where all this information is from, but because they've been sued from a few companies, you can probably guess where they got it from. But the big deal here is the token limit just increasing further, which helps lead to more, the ability to you to send a huge amount of content in a single message and do it all one shot approach. But as we move on here, there's this competition, which is the, I already forgot what it stands for, some math engineering, some last two letters. Forgot the whole thing, but maybe someone here knows it. But the crazy thing is GPT-5 in Pro mode, which is basically the thinking mode, was the first model to get 100%. A few more have done it since then, so this is not as cool as it was in the beginning. But this was a pretty big breakthrough. That was planning mode, Pro mode, which was just thinking, has finally gotten to a point that it can beat some of the more complicated competitions. And then as I look here, at the parameters, you can see here that we kind of really grown for every GPT, and everyone always asks like, what is even a parameter? People want to convert these to like brain neurons, and there's no real good comparison. Someone a long time ago said that a human approximately has about 81 million neurons in their brain. So you could kind of think as a neuron with a parameter. These really cannot be compared, but you can kind of see that if a human can roughly get about 100, and you already have models that are in the trillions, you can see that these models are becoming pretty crazy. So then the common question is like, with GPT-5 out right now, what is its parameter count? Tough to know right now. We don't know any vulnerabilities or exploits to reverse the model to figure it out. So that's just still an unknown, but people are guessing it's way over what it was on 4. So then I want to talk about real quick all the tools is, like how these LLMs are working under the hood, because I just talked about like sending text to something, getting images back, like what is actually happening under the hood. Because if you want to build this stuff and throw it into your software or use it, you have to have a bit of idea of the flexibility an LLM offers. And there are, a lot of tools these days. So if I just hammered them out real quick, you see you have code interpreting, files, functions, web, computer, image, local, tools, connectors, and MCP. So with all these here, we're going to go through them because I want you to understand what they are. Because if you're building with this stuff, developing in it, you need to understand how they work, why they work, and when to use them. Because there's a reason to use all these, individually. So right out of the gate, let's start with code interpreting. And you're probably thinking, why would you need an LLM to write code, run code? I think it's pretty obvious these days. But how many times in the beginning of the LLM were you saying like, hey, LLM, how many R's are in strawberry? And it would be like, I know it, I'm 100% sure, and it's wrong. And the reason that's happening is because tokenizers, embeddings, like they're not very good at knowing how many letters they are. They're just trying to complete a word. But guess what an LLM could do? It could just write a single line of code in whatever language is the quickest, probably Python, and say, count the letters of whatever you asked for in this string, and then do it. So code interpreting has become really crazy of how the model is working under the hood. But then your next question is probably like, well, that seems pretty insecure. If an LLM is generating code on behalf of me, what can I do? Which is why you see that so much has been invented in the past few years of like, very quick ephemeral containers that are read-only. You can't write anything except what's being executed inline. So they can't be, abused for Bitcoin mining or hacking if you can somehow trick your LLM to generate something malicious. But basically, code interpreting has been a next generation thing that has allowed LLMs to be more smarter. Oh, and I do have the cool little thing here. Like everyone remembers this, I hope. ChatGPT was very confidently wrong that strawberry had, 2 R's. And of course, the code interpreter helped avoid that. But then moving on from that, we have the file search one. And this one is incredibly powerful because ultimately, you can create a vector store. And what is a vector store? Imagine all the documents you have on your computer. You can kind of take them, rip out the text, put them in a vector store. What does that mean? Kind of saw what we did in the very beginning with tokens. Take them and put them into this 3D space so you can start relating to them, in a vector. So what is this saying here? This is saying, let's pretend you're at a business and you have all your, invoices, your proposals, you're trying to kind of do insight on your work. You would throw them all into a vector store, it would start tokenizing them and putting them into a pool, and then you can search it. So instead of you doing an I like or a like query or a regular expression or trying to find things based on terms, and you're looking into a vector space, you'll see this is how most search engines and things are working today. Because a search that can establish relativism, to terms without pure words and guessing and liking or expressions is powerful. And the cool thing about these is you can build them yourself depending on who your host is for your platform, or if you're doing it yourself. And you can see here just a snippet of the output. The amazing thing is you're getting, like a citation, like if you were doing MLA back in the day of where you got your stuff, except it's from your own documents. Except that was maybe formatting, so it might have been the wrong term. So then we have the function tool as we move on here, and this one's pretty crazy that people were building with the LLM and they were saying like, what's the weather where I'm at? How does the LLM gonna know that? It doesn't. But what people started realizing is they could build a function and say, hey, LLM, if someone ever asks you for the weather, I want you to come back to me being the person who is invoking you, ask me what the weather is. I'll look it up for you and send it back to you. So you can see here that we're basically telling the LLM that we have a bunch of tools available. LLM, you can call these if you want. Come back to me. I'll give it to you. And then we'll move on. And this is what you saw kind of right now with LLMs getting better, is because the amount of tools they have available is increasing. And then of course we have a more obvious one, that happened in the past few years, is web searching. So you can see here, like back in the day, early GPT-3 is, not searching the web. But GPT-4.5 comes out and you have the ability to immediately, much like a Google search the web, cite it, move on. And that is extremely powerful, that you could probably put in your own tools. These next tools are really crazy and kind of complex. But for one, imagine you're trying to automate a computer, like a lot of tools are working now. You try and think in your head, like, what is the automation of working a computer? But think about it from an LLM perspective. Take a picture of the screen, send it to the LLM. LLM tells you where to click. Click, take another screenshot, move it. Like, this is the effective thing of building. You might use it now with a Claude code or an open code. These actually don't work with screenshots if they're purely terminal-based, just looking at output. But the idea of a multimodal thing is just taking screenshots of your computer, instructing it where to click, and iterating this over and over again. Because this method works well because you won't need any control of any service you're using. You can do it way faster if you know how the websites you're visiting work. But this one will work with anything, anywhere, because it is working solely off, the images in the front. Which is funny enough if you want a little nerdy details of how a lot of video game cheats work these days. They work completely off the video layer, stripping it, moving it to a different computer, isolating what you need, and sending it back without ever interacting with the game. Which is exactly what this is doing, except for different reasons. So image generation was pretty cool when it came out. As you expect right now in 2026 with AI videos and AI images, this was pretty cool when you could say, hey, build me an image, and you'd get one near instantly. And you'd say, hey, please iterate it. I want it a bit more realistic. And boom, it gave you a realistic image. Like, think about just everything people are building now that are just clearly AI images. And then we have a tool that I think is the coolest of them all, which is a local shell, which is how things like, as I mentioned, Claude Code and Open Code have been released, which is the ability for one to just work on a terminal, execute commands, look at output. And in Linux, which was the idea that we're going to take a bunch of tools, every tool does one thing, it's going to do it well, and it has to be interoperable with other tools. So an LLM loves that. It can chain things together, do what it wants, looks at the output, makes another call. And this has been extremely powerful, that people sit down, talk to their computer and say, hey, I want to download all the apps from my phone, decompile them, do this. And it's like, I got it. I'll just start running them and doing it. And this is like, your brain working for you on a machine. But then we have some cool features that an LLM has, and one is the custom tool call. Because there's this world, of custom grammars, you can kind of conform a statement to something. So let's say you're trying to build something that always needs to hit a specific thing. You could fit a grammar to fit that and have the LLM be forced to, meet it. What I mean by that is, like, let's say you always want JSON from the output or any type of forced schema format. Custom tool calls really help you there. Because really the key is, ultimately, when you're working with an LLM, is you want a structured output back. And if you're getting just fuzzy, completion output that you can't, build your system with, custom tool calls that force you into a grammar are extremely helpful in that regard. Then we have connectors, and this is what OpenAI has been on the, jump for the past few months, is they're trying to grow this list over here with as many things as possible. So basically, when you're talking to your OpenAI, ChatGPT, you're saying, yeah, I'll give you access to my Gmail. And then how is that connector working? Oh, well, Gmail said, hey, if you want to read an email, this is what you do. You want to look at my email list, this is what you need to do. And then the LLM agent can do it. One, if you trust your Gmail with ChatGPT, that's a different story. But you can do all these tools. But then what did Anthropic do? They kind of looked at this, and Anthropic was like, I don't know what connectors are. Does anyone know what it's 3 letters. It'll be the next slide here. Yeah, I heard it somewhere. I don't know. Yeah. So they came out with MCP, and basically what I showed you with connectors was OpenAI's branded solution for MCP. And what Anthropic then ultimately released was an open one that is gaining steam. And what MCP is, imagine, is like the USB-C for LLM agents, is, we saw function calls, which are unfortunate because you, the computer or the developer, have to build every function for your LLM to understand. But for the weather example, why would you build a weather endpoint when you could just use an MCP server from a weather service? So what this means here is your LLM, whether it's working on your browser or a chat or an IDE, it can reach out and talk to all these different services through a standard protocol. And honestly, if you think it's complex, it's just a bunch of JSON things that's like, I'm initialized, I'm ready for tools, send me a tool list. So not complex at all. Kind of what I said there, but the biggest point of MCP is it's open source. And what we're seeing here is that the adoption is pretty crazy because things that are kind of walled in with the company are getting, not so much. Because everything that's open, whether I'm talking like an agents MD file or open source MCP, the open stuff is winning at this time. Okay, that was cool. That's all I want to talk about the history. That was fast, that was a speed through, but I hope you understand a rough bit about now what we're going to talk about, which is me in the workplace, day in, day out, what am I using and why? So here, right out of the gate, we use Google and Gmail at work, and they are now offering this like summary at the top, this AI overview. First, I hated it. I was like, get this out of here. This is a bunch of wasted space on top of the thing. But then I remembered, I'm communicating with vendors that take 3 or 4 weeks to respond. Their email comes back. I'm looking at the subject. Don't even remember what it is. And then Google's thankfully taken 100 email chains, summarizing them to 1 or 2 bullet points and telling me, and I'm like, boom, I remember. I was like, this one's starting to get helpful. So you can see ultimately kind of the fear here if you're paranoid is like, one, Google's reading all my emails to summarize them. Well, guess what? Gmail's our Google provider. They're reading them anyway. So I felt if my business is already giving me this feature, I don't need to be worried. So once I got that through my head, I was like, this is extremely helpful. But for your business, your work, I think this is a level of care if you're not hosted on, Google. If you're using Proton Mail, I'm guessing they don't have this. But then moving on to meeting notes, which is the biggest change, I think, if you're a project manager out there, is how many PMs or project managers are sitting in meetings and taking notes, writing down what the client says, trying to, distill a meeting into notes to pass along. And now you have an agent just sitting in your meeting, listening to everything, automatically pulling out, tasks that people need to do, next steps, and a summary. And this has been revolutionary. And there's so many competitors for this. Once Google Gemini offered it in Google Meet, we're like, well, we don't have to pay for Zoom anymore. Don't need to pay for Assembly anymore. Easier to stay in one, walled garden. But this has been revolutionary for us that our project managers no longer need to do what I find is kind of more, boring work of taking notes or doing tasks when an agent is just recapping everything within a minute and sending it to everyone. And for the most part, these are all fairly accurate because you could do it manually, but to see little, tags by voices and extracted next steps is revolutionary. The reason I'm saying a lot of these things for, shortcuts is we are facing in our industry right now, I work in an agency model, is we are competing with businesses that can cut costs by near 100% and build something in 100%, net zero time, because they are in this market of vibe code a solution for a client near instantly and turn it around. So how can we, a business that still builds things with automation, but still with humans, how can we compete? We need to speed up everywhere. Every single where. So what we have is, AI in every aspect, even for our servers now. So we host on AWS and they have guard duty. Guard duty was around long before the LLM craze, but now that it's empowered by it. So what is scary right now is we have a very interesting problem. In the past few years, anytime you get a SSL certificate, that SSL certificate is published into a transparency log. And it is done for that for a multitude of reasons. But that has also become an insane vector. So what I mean is let's pretend you just bought your brand new website for yourself. The second that SSL domain is made, it's put in a log and attackers see a new SSL domain and they immediately attack it instantly. So what we found is with a new domain minted, 11 seconds later it was attacked by over 50 IPs and hammered for every possible vulnerability you can imagine. So if attackers are getting near 1 minute turnaround time, then how can we as a defense, combat with that? So we have to put AI also on the defense. So what guard duty does is it sits, wherever you install it, for us on our container, and it sits there. And if it sees something that is not normal, because it's an LLM also doing things, it's like something is wrong and it reaches out. And that for us has been game changing. It was a couple weeks ago that we had a Next.js CV, a pretty bad one. It became a remote code execution. So not sure if anyone was affected by that, but we immediately, use GitHub. GitHub's really cool. Dependabot sent us a bunch of PRs. We were like, okay, we're covered. We forgot one. We forgot a Docker project that actually brought in Next.js and was not described in its dependencies, which is a different, reason. And GuardDuty alerted us that there was a crypto miner on one of our services, which is crazy. But thankfully, it told us the minute it happened. So we terminated the server, identified the problem, upgraded the dependency, and patched the project. But the scary part is how long would it have taken you to notice that without a GuardDuty? Would you have noticed the spike in CPU? Would you even have a monitor on your server to notice the spike? Would you block outbound traffic? Does your server even block outbound traffic? Do you have a whitelist? And the amazing thing of GuardDuty is it just looks at your server and knows the pattern. So anything that's outside of that, you get a warning. And it's instead of the alternative of what you may have done in the past with a Datadog or a system that you're constantly looking at alerts. And an LLM generally knows a false positive from a real one. And I know I talked about this one a lot, but this one to me has been my greatest time save in work, is I can pretty much rely on GuardDuty to keep things safe. I can, retroactively react to something. Talk about GitHub a lot here for the next few slides because we host our code in GitHub. And I think we have a GitHub guy here, so wherever you are, cool. Oh, well, sweet. I'm going to talk about Copilot a bit. The first thing it can do is what I call as an agentic workflow, is it can actually build a pull request for you. So what I describe here, unfortunately, I'm just showing you hobby code, just a little Halo project I run. But let's say you get in one morning to start work and your client has emailed you a bunch of feedback of things they want to change. Predominantly before AI, how this would go is, okay, let's go through this feedback, send it to the team, estimate the work. If it's easy, do it. If not, assign it out. Now what happens is email comes in, send it to Copilot. Copilot just chunks through the work, puts up a PR. Your question is then, is it good? And that is really depending on the project. If you have a highly opinionated project, and what I mean by that is, let's say we work a lot in PHP and Laravel, a highly opinionated framework. If you work in like Vue.js or React, opinionated things. If you built a homegrown system in a language, not opinionated, it doesn't know what that is. Then maybe you documented for it. But opinionated frameworks that are forcing you into guardrails are empowered by, a Copilot to meet those demands. So for us, we've had immense success in Copilot just authoring PRs for us. So now an engineer is just reviewing what an AI did and merging it with a huge turnaround time instead of estimating working work that, would previously cost more money. So we're starting to be able to compete now with, more of the vibe coding approach. And GitHub Copilot is pretty cool in the sense that, you can just respond to it and it will fix things. So if you don't like it, what we really prefer at our work is we do 2 shots. If it cannot fix it in 2 tries, an engineer takes the ticket from there. And we like that approach because, we're not wasting too much time arguing with something. We're just, iterating it ourselves if there's no success. So then the cool thing too, what we have is GitHub Copilot for the review aspect. Let's talk about there's no AI at this point. This is a human doing work, a human reviewing work. You can add GitHub Copilot to review code. And what's really interesting about it is it generally understands a project and does a review in under a minute of your project. And for us in an agency model, let's say we need 2 code reviewers for any change to be merged, but we're sitting there waiting on teams to free up to review code because we have an influx of work because of everything I just described. If we can have an AI help us by giving us a second hand in review, that's pretty cool. The example here is I'm a maintainer for Fastlane. If you guys have never used it, it automates Android and iOS build pipelines. I'm just always adding Copilot to open source, pull requests, because for me, if I had Copilot and Copilot's happy, then I can just look. I don't really want to waste my time looking at stuff if Copilot isn't happy. So that's generally the approach I've taken. And then finally, I have Copilot Chat. And you would think this one's odd. Like, why would I want to talk to Copilot for a project? But especially for the business I'm in of agency model, I might have 30 active projects right now. I surely don't remember how some of them work at the internal levels. So the client emails me and says, hey, how does the KDA formula produce? They're not emailing me that. This is the Halo project still. But I can then do a Copilot Chat on that GitHub repo and say, hey, I know the client just asked me this. How does this work? It points me right with sources to where the code is. I can click to that code, remember it a bit, and respond to the email. And this has become a bit game changing because you'll have the client, that only emails every few months, and you have to ramp up on a project you haven't touched in 6 months. And with this case, Copilot can ramp up your project and really help in there. Of course, now I'm going to get into more of the agentic, like on your computer working for you. I really love PHP Storm. If you work in the IntelliJ suite of software, then that's my cup of tea. And there they launched Junie. This was basically Cursor. Cursor was first, Junie probably third or fourth. But what Junie does is same deal like we saw with GitHub Copilot, except in my IDE. I say, Junie, every time I start a ticket myself, I say, Junie, do it. Junie starts, and if I don't like it, I toss it. If I like it, I edit it. But I always start my work now with Junie. And all this is what you saw with Copilot working on a GitHub repo. Junie will just make the changes, tell it, and leave my repository in the modified state. So I can do it. And based on your project, this might go great or not great. And what I mean by that is my projects normally have an agents MD file, which says, hey, here's how you run the test, here's how you lint it, here's how you make sure it works. And the benefit of that is when Junie's done working, the test still passes my linter, and all I'm doing is reviewing what it did to make sure I approve of it. And this is next level. Unfortunately, all this stuff does cost money, but hopefully, if you're working at a business, they're footing the bill for this stuff. But also, if you're a student, most of the stuff is free. So, best of both worlds. Then finally, I want to talk about open code. But before this, I think you would probably recognize it as Claude Code if you use those. So the reason I use open code, and here's a real example, is I audit Android apps for clients and do research. So one client sent me a request that they have a fleet of apps on the App Store. It was like 15. And they said, we need to do assessment to figure out what applications need to be upgraded to API 36 and which ones have fine and coarse GPS permissions. One, I thought it was an extremely weird ask for me to decompile apps to give them information they could find in source code, but that was the request. So I asked open code here. I said, hey, my Android device is connected to my phone. Can you use ADB and install all these apps, pull them from my device, then decompile them and build a report of all these fields and do it for me? And that's called like a one-shot approach that I did not train anything. I just told it to open code. It asked me one question. It was like, I found some apps that are splits. What do you want me to do? And what do I mean by splits? Like if you're not familiar with the Android industry, like recently Android has started working in the fact that when you download an Android app, you're getting not one APK, you're getting the base. You're getting like an English one, an XHDPI for high density assets, and one specifically for your architecture. So OpenCode was like, I don't know what to do. There's 5 apps. And I was like, good catch, OpenCode. I want you to pull all the splits, run APK editor, merge them together, and then decompile that. And just with one question it asked me, I looked up in the top right-hand corner, and it billed me like $2.70, and it was done in 4 minutes. And I was like, this is insane. Something that would have normally taken me, 4, 5, 6 hours to do was done in under 10 minutes and only cost $2. And I was like, for me in the business, now I'm working on something else while that's working, game changing. I'm triple tasking, multitasking. While that's working, I'm responding to GitHub PRs that are also by agents. The amount of context switching is insane. And I'm having to keep up with this because that's who, the competitors are doing. So it's a bit crazy. Of course, I always have to talk about GPT because I'm not Google searching anything anymore. If I'm Google searching, it's going into ChatGPT. Because if I'm Google searching and one, I'm getting an AI blob at top that I hate, and then 5 sponsored things that I hate, and then an ad that I hate, like what is the point of Google searching when the only result I like at the bottom is someone that has been SEO farming for 10 years. Like, to me, it's not great. I have no need to use it. I just ask anything I want to GPT, and it's doing a better indexing job. Now, there will probably be a time in the future that ChatGPT will not be great for this. Like, people will figure out how to abuse it, or they need to monetize it better. But for now, I'm not Googling things anymore. That's all to GPT. Finally, I wanted to talk about one thing that I think this one animates. Yes. Okay, so went on vacation, came back. Some of my Slack channels had like 400 messages, and this cool little thing popped up that said, summarize all your missed messages. And I was like, I don't know if I want to do that. And one, should I even click the button? So I clicked it, and it summarized everything to 3 sentences. And I was like, okay, I'll roll with that. Because if you're sitting in your car coming back from vacation, do you really want to read all those, or just scroll to the bottom and say I'm caught up? And I gave it a shot, and I was like, okay, I like it. So if everything's adding things that can help you summarize stuff, then I think it can be helpful. I talked about all the things, though, that are helpful, and now I want to talk to you about things that I hate with a passion that have been shoved in my face. One is I use Jira. Our company uses Jira. Jira is shoving this Rovo in my face everywhere. Hate it with a passion. Every time I'm trying to type in a box, it's popping up and it's like, do you need help turning this into notes? No, I am writing a comment that's gonna be less than 4 words, like pass fail with a bit of detail. And this thing is shoving it in my face constantly, like, do you need help writing notes? No, I do not. I don't need any of that. And it takes up your space. You can't find a way to disable it. Annoying. Then you think it ends here with Rovo, but it doesn't. Rovo, again, decides to summarize a ticket for me because there's 40 comments, QA's failed, devs passed it, but then Rovo says it's against their acceptable use policy. And I think, then why even show it to me? Why even put it in the summary box? Why even take up my valid space to tell me it's against policy? When all this is us discussing input boxes on a website. Like, to me, terrible implementation. Can't get rid of it. And why Jira wants to constantly do this blows my mind. Maybe this will be good at some point, but to me, they have upset me so much already that if they charge for this, I will fight that we will never pay for this. And then one other one that really bugs me is Gmail. Gmail started adding this suggested response. And I'll tell you how funny this is I respond to so many emails every day, and I'm always like, hi, 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 hi. This one does say hi. When Gmail started this suggested reply, it always say, hey. I was like, you can't look at the 40,000 emails I've sent and tell me that I've never used the word hey. I always say hi. It's gotten better. Now it does say hi. But what's crazy about this is every single suggested response it wants to make is wrong. For one, I don't talk like that. I will never do that. And that's not how I talk. And then what annoys me is when I click into that box to actually type my response, it puts it there. So your question is, how do you respond in Gmail if you don't want the suggested response? Okay, you took a pattern I've been using for a decade, just clicking into the box, broke it. Now I have to train my muscle memory to hit reply or do something else. Gmail, hate this with a passion. But now, enough about that. Let's talk about building things with AI. Right out of the gate, your first question for everything, if you're gonna build something with AI, is what model you're gonna use and why you're gonna use it. And what I mean by that is there's this notion of SLM versus LLM. And LLM is the large language model. What is SLM? Small language model. Because people started realizing that you don't need an LLM that has 2 trillion parameters in it if you're trying to do something specific. Because one, it'll be quicker and cheaper if you only need something that can take CSV data to JSON. Like if you're doing something as simple as that, one, I wouldn't use an LLM. That seems structured. But my point being that an SLM that you find targeted to your industry is infinitely better than an LLM. Then the next thing you have to figure out is if you're looking for completion or reasoning. Maybe you're working with someone or something that you can think it can work in the background, it can plan stuff out, or it has to be fast in completion. Because even a reasoning model with zero thinking is still going to be slower than something streaming out a completion thought. Something you have to consider. And then of course, obviously you have to think about a budget. Thankfully models are getting cheaper and cheaper and cheaper by the day. But some of these, especially on pro mode, you don't want to run a single query and end up costing $1. That'll ramp up. Modality is a very big, important thing to mention too. is maybe you're just generating images or video, or you're strictly working in text. If you find a model that fits, your criteria, that's extremely important based on what your modality will be. And then availability. What we saw was an interesting thing is when it was kind of OpenAI really leading the market, is OpenAI would come out with a model, people would use it, you would hit rate limits, you couldn't roll it out to your platform because it wasn't fully available. So people did a trick is they would deploy the model in Azure because Azure had the same models of OpenAI. So you point your platform to Azure and OpenAI and load balance between them. And then people started thinking, that's absolutely insane. Why am I doing this? I could just put this on-prem and get an open source model, and then I control the availability. So another thing to consider. But finally, what you want to really look at is what are the limits of this thing? And I'm talking about something like time. Like, do you care that a model, only has content up to 2021? Do you need a model that is updated like every 2 weeks with recent content? Do you need something that can take a 1 million context window to single shot stuff, or something that can only take, 56 kilobytes? All these things together, you would think, this is a lot to think about. And you would think, oh, maybe there's only a few to choose from. But unfortunately, if you go to Hugging Face and look at their model list, there's like 15,000 different models now. And depending on what you're doing, it could be quite a fun research task to look at it. If you ever heard of the model YOLO, and you think it means you only live once, well, in the model world, you only look once. And what that meant is the YOLO models are crazy. YOLO models are basically what's being used for people to, look at a video stream and point out what's in it. So we set up a YOLO model looking at a live stream of a desert just to test out flexibility. And of course, it was like bison, giraffe. And I was like, sweet, it's working. So if you ever mess around with these models here, you can kind of see ones that are, performant in an area based on what you're trying to build. Let's say you're building a random tool that you're just going around taking pictures of potholes and trying to look at the depth of them. Like, maybe there is a model for you that can do depth determinist, like measuring of images in depth easier than the others. So research on models is a pretty big deal. One thing that an LLM will ultimately do in every single solution you build is take something unstructured and make it structured. And what I mean by that is, when you build a solution with an LLM, in the past it was a streaming bit of text that you had to pipe into like a regular expression, a where is, what is this, and look at it to figure out if there was a match for what you're looking for. But now in the era of AI agents where you can force a JSON schema return with a custom language, taking things that are unstructured to structured cannot be, ignored as an extreme powerhouse of an LM. If you ever remember the days of trying to get, random PDFs or random Excel documents, unstructured CSVs, and having to build a system to dynamically know, okay, I'm going to present the user a system that allows them to remap columns and do things. Who cares? Give it to an LLM. LLM will immediately give you a structured format from an unstructured format with extreme accuracy. And to me, this has been the game-changing thing. You go into a business and you take a process they're doing, you don't even have to structure it because the LLM will sit in the middle and do it. This is really, really game-changing. And then another game-changing one for our cruise ships, because we work a lot on cruises, is the translation aspect. Is we have this issue that, how can you translate it on board, you can translate hard-coded text easily. But what happens on a cruise ship is people, day in, day out are coming up with new daily events, and they're happening on ship. It's rare for some ships, unless it's done by headquarters, that everything is made ahead of time and pushed to the ships. Some ships make up their daily events, with the service and staff they have on board every day. So what is crazy about this is now on-prem LLM agents can take all the stuff they do and translate it to every language of any person that's on the ship and give them a daily, summary on their, their stateroom of what their day is in their native language. And you would think this might be translated wrong. We're worried of it. And we were too, but then we kept running tests, versus paying someone. And this was, nearly accurate 99% of the time. A couple of things that got messed with that we trained it with is like formal nouns, or what it refers to if, a place on the ship is named something that confuses it. Outside of that, formal nouns, we had extreme accuracy, LLM one-shotting translations for the global market on a cruise ship. which is crazy to think about because people used to go to, Google Translate and try it all out. Kind of speeding through this, but AI supporting software, what I want to talk about for a bit is Langfuse. And I've talked about all this of like what you're building out and doing. But when you're sending LLM calls to the LLM, what is it actually doing? Like, do you know what it costs, how many tokens it did, and its response? What happens on Langfuse is tracking everything. It's introspecting all your calls you're making. And if you leverage Langfuse more, it can keep your prompts. And what do I mean by that? Let's say you put a prompt in your system. You don't want to have to issue a code deploy to change a prompt that should be able to be A/B tested on the field for something. So Langfuse has this amazing ability that you can version prompts and then using their data sets, run your prompt against a new version, and it will then use another LLM, LLM as a judge, and test them to be sure they still pass. Because you never want to be, you want to be extremely sure when you're changing a model or a feature that your LLM still works. We heavily use this for some of our, more chat-based things. For a cruise ship that may have a help desk agent that's, a bot or a menu one to help them at the restaurant. These are all A/B tested with Langfuse, and all their API calls funnel in here. So we can see our cost spend and, the usage of it. So unfortunately, if you build something into a black box, which most LLMs are, you want some level of introspection, which Langfuse offers. Good news too, OpenAI is getting closer and closer to offering this in-house if you use them. But if you use other providers, then it's just better to stick from Langfuse in the beginning. And we love using it. Then we have another one here, OpenRouter. And as OpenRouter, as the name suggests, is first we had OpenAI that built a pretty generic looking API, and then Anthropic built one with OpenAI compatibility mode and Gemini with OpenAI compatibility mode, but they built their own too. So if you're building something as an engineer and your boss comes up and says, hey, we want to switch to Claude now because we're not liking the pricing on GPT-5. You're like, holy cow, the APIs are different, I can't do anything. Well, had you built against OpenRouter in the beginning, they created a unified experience that talks to, at this point, I don't know what it says on there, but 60 different providers. And as you can suggest, think about, this is like a middleware that it's like, talk to OpenRouter, they'll go talk to all the different ones. And that's kind of what our business on cruise ships does, which is funny enough. When you take all the different systems on a cruise ship, you have your like onboarding reservations, PMS, and you unify them all into one API so your app can do it. That's exactly what our business model is, funny enough, for cruise ships. And that's exactly what OpenRouter did for LLM models. So we love it. We love this because we can, with the power of Langfuse behind it, we can take one of our services and run it against 5 models. So what we did a couple days ago is we ran against, Claude and OpenAI and a lot of the more open ones and tried them out, and then got to look at reports in Langfuse to look at the price difference, the success difference, and look at them immediately with cool reports. And we do this because we were slowly in this transition away from LLMs, because not everything needs a massive large model versus the tinier models, and testing them with Langfuse allowed us to do it. I think this is towards the end here, but what I wanted to kind of recap here is it's really important to kind of jump into a model and research them. There's over 15,000 of them now. You kind of want to make sure you're guessing right. But thankfully with Langfuse and OpenRouter, if you build out with that, a guess is not too important because you can swap on the fly. And once you understand the tools, which I went through all of them, is you can figure out what to build and why to build it, because you can leverage an offering an LLM has. But I'd argue you to always depend on structure. Is for every single LLM call we make, we force the LLM to return it to us in a JSON format that we understand. And we do that because then downstream systems can type the response to a typed, strictly typed data form that we know with confidence that if it doesn't hit that format, we are retrying the call. And we do that because people are always worried about hallucinations. But if you force an LLM to meet your constraint down to the data types and the sizes, what things are, if you get a hallucination through that, it's way worse because it has to fit your constraint. And that is something to always look at. And then finally, introspection, which is unfortunately LLMs or SLMs too, they're kind of a black box unless you get into the, internals of transformers. And if you add something on top to, look at the token count and how they're working, request response, and can do that for a cheap offering, then you need introspection. And we've really loved LangFuse for that, but there's plenty of other competitors. And it helps us to see this like rolling, that's definitely the school day starting and ending, school day starting and ending, but that is extremely powerful. And I think that is it. So thank you guys. Well, any questions from anyone? Yeah.
So you showed a number of tools that are, I've used some of them. OpenRouter is wonderful, but from your experience, from your point of view, which is like the tool for the everyday developer, maybe a product manager that does some development that has a multiple components that you could use as an everyday tool instead of having 5 different things open?
Yeah, to be honest, that would be open code for me, because open code you can plug into any provider. I'll say that except Claude now. Claude Code is banning it, or Claude is banning their API keys being used for open code because they're claiming that it is violation that a tool is being built better than their tool with their own API keys. But outside of that argument, like what I did with our PMs is I said, PMs, here's open code, here's how you use it. One of our PMs said, I need help generating, a change log from all these Jira tickets. And it built a tool that automatically built, a change log for tickets. And then I'm thinking, well, we can do that through Jira, but the Jira one's dumb. It just takes tickets and takes the titles. Like this thing read the ticket, built a business reason, and I didn't even sit with the PM once. Did it entirely yourself with open code. So to me, if I gave you one, open code.
Any more questions? Cool. Well, hey, thank you very much. You wanna wrap it up?